All right, hello and welcome to the Pre-Calc video. This is Unit 2, Section 6, which is graphing logarithmic functions. So typically, historically, logarithms are something that scare you and you don't like them because you don't understand them, you don't understand what they're tasking and all that kind of crap. But let's kind of talk about it. So somewhere in your notes, I want to do this. I'm going to ask you guys the question, 3 to the what power is equal to 9? Okay, what's x equal to in this case? 2, right? So, and you just kind of think about that. You just go, okay, 3 to the what power gives me 9. That's going to be squared. Okay, what about, 2 to the what power is equal to 8, and that would be 3, right? And so, the thing of it is this is an equation that you are solving, and you know what the variable is that you're supposed to get, okay? But are you doing any algebra, or are you just thinking about it? You're just thinking about it, okay? You're not really doing any algebra. So now let me ask you this, all right? 2 to the what power gives you 2.3? No idea, right? Yeah, like how do you solve for x? What's x equal to in that case? So the question is, and here's the thing, these are exponential equations, okay, that you're trying to solve. You're trying to solve for an exponent. So I'm going to write that down. That here, you are trying to solve for an exponent. But the problem is that we don't really have a technique per se to solve for an exponent until now. Okay? So what I would do here, the only way for me to solve this is to use a logarithm, okay? And what you would do, given an equation like this, if you had 2 to the x is equal to 2.3, then you would do log base 2 of 2.3 is equal to x, okay? Believe it or not, when you write it like this is a number, okay? This is a number in exact form. If you put this in your calculator and you evaluate it, then you get a number, okay? So let's kind of think about this for a second, okay? When we have algebra, okay, when we think about algebra and solving equations, okay, when we solve equations, and I think I did this in the last video, but maybe not. When we solve equations, I always think of the word opposite. Okay? Is that how you spell opposite? Yeah. I think so. Okay. So if you had, what's the opposite of addition? Subtraction. What's the opposite of multiplication? Division. Okay? Those are the standard ones. Those are the ones that we know about, right? What about the opposite of x squared? That'd be the square root of x. Okay, these are all opposites. So then the question is, what if you raise a number to a variable? The opposite of that is a logarithm. Okay, and that's what a logarithm allows you to do. Logarithm. Is that how you spell logarithm? Yep. Okay. So that's the idea, all right, and we're going to get used to it, and talk about it, in depth, but that's the basis of it, okay? That's how, and I just want you to know that that's what a logarithm is, and that's how we do that, and that's what we're doing, okay? It allows us to solve for an exponent, all right? So, consequently, all right, well, okay, let's take a look at our objectives before we do anything. Okay, we want to identify logarithmic functions. Not that hard to identify a logarithm because it uses log. Determine the domain and range of logarithmic functions. And we want to identify and analyze the graphs of logarithmic functions. So we're not like solving for anything right now. We're just kind of figuring out what exactly they are. All right, so here's what you've got. Because I used that example before of an exponent, okay, the way that we get logarithmic functions is by first knowing the original exponential function, okay? And what we do is we have this exponential function, 4 to the x. Then what we want to do, how we're able to do this is we're able to actually look at the inverse function of that, okay? And the inverse function of 4 to the x is, if we want to do f inverse of x, then that would give us log base 4 of x. Okay, that's our inverse function. Inverse is like the same thing as me saying opposite, okay? So all those things that we had up there, it's kind of the opposite. Now, the idea, what I want you to notice on this is that you have a couple interesting points. Notice how you have the point on your exponential function of 0, 1, okay? And that point, if you reflect that across this line y equals x, you have another similar point. See that? And this is the point 1, 0. Okay? Now, this is what an inverse is, okay? And what's happened between 0, 1 and 1, 0? What did we do there? Switch your x and y. That's what an inverse function is. In this case, and that allows us to solve, to figure out if we know values on an exponential function, we switch the x and y values and we can figure out what's on a logarithmic function, okay? So, that's the thing. Notice that, in an inverse function, okay, when you have an inverse function, that's when you switch the x and y values, okay? Notice also on this graph that you have another point here, and this is the point 1, 4, okay? Do you notice anything about the inverse?
Same distance from the reflection line.
Well, when you reflect it over that line, you reflect that point, think about the point that you get over here. You get the point 4, 1. Opposites, they're switched, okay? And that's what an inverse is, all right? So you have to understand an exponential function in order for you to understand what an inverse function is. So a logarithmic function. Here, let's look over here. Okay, so a logarithm is the exponent of a given base that results in power. Okay, yada, yada, yada. Okay, so I want you to look at this statement right here. Okay, it says if b to the a is equal to x, okay, then we get log base b of x is equal to a. Okay. And you're sitting there and you're looking at that and you're like, okay, what is going on? All right, it's kind of hard to read and kind of hard to understand. That's why this is all so confusing. So let's take a look at that, okay? And let me kind of talk about that. If you've got b to the a power is equal to x, okay? The b is, what do you guys know what we call the b? We call that the base. Okay, this is our base. Okay. The a up here, what do we call that?
The exponent.
That's your exponent. Okay. And you take b to some power, it gives you x. Okay, b, a, and x are all numbers. All right. But let's say we wanted to figure out what a is equal to. Okay. And that's the key. A is equal to, all right, to get it out of our exponent, you have to use a logarithm. And you have to say, okay, this is just log base b, and you put a little b there, of x is equal to a. all right? That's by definition what a logarithm is. So what I'm asking you guys to be able to do is to be able to look at something like this and then write it as in log form and vice versa. You have to be able to look at something as an exponential equation and then rewrite it as log and vice versa. You should be able to look at a log function and write it as an exponent. Okay? Now, one way that I think about this, and here's another definition, you know, if you've got, say, I usually write it like this, y equals b to the x is how I usually write it. Okay, here's an exponential function. Okay. All right. And then if I wanted to rewrite this in log form, I would say log base b of y is equal to x. Okay. This is what I usually do. All right. This is how I remembered it. This is kind of how I had to figure out how I went from one to the other and vice versa. Okay. The way I go this way, okay, to go from exponential into a logarithm, so logarithm function, okay. The way I go this way is I have to think about, okay, I'm solving for an exponent, okay? That's how I have to think about that. That's the way that I do it. Whatever you guys want to do, that's fine with you. But I just go, okay, here I have y equals b to the x. X is an exponent, so I need to solve for that. I need to get that by itself. So whenever I have an exponential function and I rewrite it as a log, I go, okay, x is equal to log base b. B is your base of y is equal to x. Now to go the other way, and this is the story that I always would tell a student, was, and let me rewrite this as log base b of y is equal to x, okay? Given a log equation, putting it back in exponential, I would do this. I would say that, okay, in order to get rid of the log is being supported by this b right here, okay? And the b is sitting there and it's going, all right, log is 3 letters. It's too many letters, okay? There's a lot of pressure on this b to support the log, okay? So b looks over at the x and sees the x and it's like, you know, I could support the x, all right? The x is, you know, seems like it's a nice little support system and I could do that. So the b, all right, drops the log, okay? So the b moves over to the other side, okay, drops the log falls down into the abyss. You're left with y, and then you take the b, and the b now supports the x. And so you get y equals b to the x. That's how I remember it. All right? So if you're thinking about, okay, how do I remember this? And you guys will do this again and again and again, where you'll be able to go from, you know, one to the other, is kind of just go back to that. Okay, the first step is solving for an exponent. The other is the b is sick of supporting the log, so it looks at the x, supports the x instead. Okay, that's how I think about it. That's how I remembered it. However you guys remember how to do it, that's up to you. Okay, so, all right, so you have all that stuff, all right, and we all kind of talked about all this earlier and all that. You know, and this was even that same equation that we had. All right, that we talked about before here. All right, because remember, you know, we knew that 2 to the what power is equal to 8, right? Remember doing that one a few minutes ago? If we wanted to figure this out, what the exponent is, all right, we can rewrite it like this. Log base 2 of 8 is equal to 3, all right? So that's the idea, okay? Okay. And we've already kind of talked about a logarithmic function is a function that can be written as y equals log base b of x, where b is greater than 0 and b cannot equal 1. And we know that they are inverses. Okay, we've already kind of talked about that. So let's take a look here. all right, it says, what is the inverse of the logarithmic function? So a log is an inverse of an exponential function, so therefore an exponential function would have to be the inverse of a log. They can go back and forth in between the two. So like I said, you know, if you've got log base 2 of x, okay, is equal to y, all right, if you wanted to find the inverse, okay, of this, then what you do is you switch the x and y values and you solve for y, all right? So, you know, to turn this back into an exponential function, and this is going to be the answer here, but what you do is you get log base 2 of y is equal to x, and you solve for y, okay? And so remember, you take the 2, you move the 2, you shove it underneath the x, drop the log down, so you get y is equal to 2 to the x. And then to put it into inverse form, we change y to f to the negative 1 power is equal to 2 to the x, okay? And that's what you get, all right? So let's take a look at the next one, okay? It says the point negative 1 comma 0.5 lies on the graph of f inverse of x is equal to 2 to the x. Based on the information, which point lies on the graph of the function log base 2 of x? So remember that, you know, here's your exponential function, okay? And then your logarithmic function is just reflected over the line y equals x, okay? And if you've got the point on this graph, which is negative 1 comma 0.5, then what would the corresponding point be on the inverse function, on your log function? What do? You just do what? You switch it. And so you would say this, that you have the point 0.5 comma negative 1. And that looks about right, okay? This point looks like it's at about 1/2 negative 1, roughly speaking, okay? And so that's all you would do, and that's your answer right here, okay? They're inverses. Switch the x and y values, all right? Okay. So now, all right, we want to graph this logarithmic function. Now, here's what I do, all right? I think of this function here. In order to graph my log function, we have to know how to graph the exponential function. So if you've got this, if you've got, say, a table of values, here's x and here's h of x, all right? And your function is 2 to the x. I've got three values that I'm looking at, okay? For my x values, I'm going to plug in negative 1, I'm going to plug in 0, and I'm going to plug in positive 1, all right? Now, if I plug in negative 1 into that function, okay, if I do h of negative 1, then I'm really just doing 2 to the negative 1 power, which is just going to give me 1/2, okay? And that's when you have that negative exponent, you just move it down to the denominator, okay? So when I plug in negative 1, I get a value of positive 1/2, all right? What happens when I plug in 0, h of 0? I get 2 to the 0 power. What's that equal to? 1, okay? Anything to the 0 power is 1, all right? Then I'm gonna do, okay, what's h of 1? And that's just going to give me 2 to the first power, which gives me a value of 2, okay? These are the easiest points that we can put on the graph, okay? Negative 1, 0, and 1, always, okay? And so, but I want you to notice that these points are on the graph, okay? This is the point 1, 2, all right? This is the point 0, 1. This is the point negative 1, 1/2, okay? So now, what's a logarithm? A logarithm is the inverse, and what do? You switch the x and y values. So, and the one thing we do know is that they are reflected over the line y equals x, okay? So the inverse, you know, if I wanted to do the inverse here, okay, then then I have my h of x and my x column, all right? And all I'm going to do is switch these around. And I've got, okay, I've got the x value of 1/2. equals -1. Actually, in here, let's do this. This should be the x, and this should be the h inverse of x, okay? So I've got 1/2 -1. Well, let's graph that, all right? That's that point right here, 1/2 -1. Okay, the other point that I know is on the graph is the point 1, 0. Okay, and all I'm doing is getting that from here. I'm just switching these x and y values, and then I'm plotting the new points. Okay, and that point is right here. Okay, the other point that I have is the point 2, 1. And that point goes here. All right? Now, the thing that you have to realize is that, another thing we didn't talk about is that the exponential function has a horizontal asymptote for the x-axis.
Oh, on both sides. Oh, no.
Well, just as it goes this way, it's just going to approach the x-axis and it's never going to hit. So therefore, what we have to do is we have to think and go, okay, well, then the logarithm function would have to be asymptotic to the y-axis because they're inverses and they're switched. So therefore, you have this, and you draw the graph, and it's going to look like that.
It has a vertical asymptote.
Has a vertical asymptote. Okay? So, and that's the thing. If you know what your exponential function points are, which we do, and you guys know how to do that, it's easy to plot the log points because they're just x and y values are switched. Okay? Reasonable? Yeah. All right, let's take a look at this next question. Okay. Says that the inverse of a logarithmic function, okay, here's your log function. The inverse would be the exponential function, okay? It says what values of a, b, and c complete the table for the inverse function. So if I plug in, and it's just kind of just asking, if you've got this function, this log function, what's the inverse going to be? Now, what's going to happen when you plug in 0 into your inverse function? What are you going to get there? If you do f inverse of 0, that's going to be 0.5 to the 0 power. That's going to give you 1. So b is equal to 1. Okay? All right. And then it says this. All right, well, what happens if I take 0.5 and I raise that to the -1 power? Then that's going to be 1 divided by 0.5, which actually is going to give us a value of 2. Okay? And then if I do 0.5 squared, so 0.5 squared, that's going to give me 1/2 times 1/2, which is going to give me 1/4, which is 0.25. Okay? And so this is going to give me a value of 0.25. Okay? And which graph shows the logarithmic function? It's not this one. Mine's screwed up. I'm sorry. I'll let you guys kind of work on that on your own. All right. But let's go ahead and talk about the domain of, and we can read all this crap or we can just look at it over here. All right. So here's this graph. Okay. And you have your exponential function and then you have your logarithmic function. Now, your exponential function, okay, and I'm going to put that in orange. Okay. So you've got f of x. What's the domain of f of x? Domain is your x values.
So, but x could be all real numbers, right?
Right, because you're plugging in negative numbers, you plug in 0, and you plug in positive numbers, and you get y values. So your domain goes from -infinity to positive infinity. Okay? But what about the range?
Has to be above 0 since it has that horizontal.
Yeah, so you have a horizontal asymptote. You can't have negative y values or 0. So your range goes from 0 to positive infinity. Okay? But if I look at the inverse, if I do f inverse of x, what's the domain on that function? Where do I have x values on this function?
Above 0.
Above 0, yeah. So notice, and remember what happens. To go from a function to its inverse, you switch the x and y values. So look how the range was from 0 to infinity. That's what the domain is going to be on your logarithm. So you have to write that this is going to be from 0 to positive infinity. And then the range of your log function is going to be all real numbers because you can get negative values, you can get 0, and you can get positive values. So this range goes from negative infinity to positive infinity, okay? This graph, your function, okay, the asymptote, you have a horizontal asymptote at the line y equals 0, okay? That's the x-axis, okay, also known as the x-axis, okay? And then on this one, on your log function, you have a vertical asymptote at the line x equals 0, which is also your y-axis. Everything just switches. It just gets reversed. And that's the fundamental thing, okay, is that if you have an exponential function, you can figure out its inverse, okay? All right. It says, which of the following explains why f of x is equal to log base 4 of x does not have a y-intercept? Okay? And the thing that you have to think about is this, okay? The reason why this doesn't, let's look at the graph. It's asking, why does this graph not have a y-intercept? And you have to go back to this function up here. And you have to think about, well, the reason why this doesn't have a y-intercept is because your exponential function doesn't have an x-intercept. Okay? So when you look at this function, you're like, okay, well, this doesn't cross the x-axis. So its inverse doesn't cross the y-axis. They're just switched. Okay? And so you have to think, okay, there is no power of 4 that is equal to 0. Okay? So the question is, 4 to the what power gives you 0? This is no solution. There is none. And the reason why I can say that is because, when you plug in positive numbers into this function, you're just going to get really big y values. You plug in 0, you're going to get 1. If you plug in negative values, you'll get a fraction that's not going to get, and it's always going to be positive. It's never going to cross the x-axis. So that's the thing, is like, when you have this equation, 4 to the what power gives you 0, there's no solution, okay? And so the answer to this question is this, okay? And then it asks, okay, well, what's the x-intercept of that log function? And that point here is going to be the point 1, 0. Okay, the x-intercept is always going to be x equals 1. Okay? That point is always going to be on the graph. All right? Okay, so then it says this. What happens to the value of f of x? So what happens to the y values as x approaches 0 from the right? So as you take a look at this, as you approach 0 from the right side, what happens to the y values? What do those values approach? Negative infinity. That's a limit. That's what she's doing in calculus. Yeah. Okay, so then what happens to the value? So then what happens to the y values as x approaches positive infinity? So if you go the other way, what happens? The y values are just going to get bigger and bigger and bigger. It's going to approach positive infinity. Okay? All right. So then, and you do have these transformations on these log functions, okay? So if you have and here's the thing, okay? If your base is positive, okay, on these two graphs here, then you're going to have this general shape of a graph that does this, okay? If your base is less than 1, then it's going to have a graph that looks like this. The thing that you need to consider here is that all these graphs intersect and across the y-axis at the point 1, 0. Okay? And that's something that's always going to be the case in a log function. All right? We'll take a look more at those types of things. Okay? All right, so then you have this. Okay, in the problems below, you have this log function, log base 2 of x and log base 10 of x. It says, how are the graphs of f and g similar? Check all that apply. Okay, and here's the thing, is that you're going to have something like this. They're all going to cross the point at 1, 0. Log base 2 of 10, you know, they're all going to have this general shape. And let me check up here. Okay. So this is log base 2, all right, and let's just do another graph, and let's just say that, all right, is log base 10, all right. So they're going to be similar, okay. You know, they both have a y-intercept of 1, okay, and that's not the case, okay. They don't have a y-intercept, all right. They have an x-intercept of 1. They both increase from left to right. Yes, they will both go up and to the right as you increase. Okay, so that is true. All right. They both have an asymptote of x equals 0. Okay, that's the y-axis. Okay, and that's true. Okay, they are asymptotic. They will not cross the y-axis. All right. They both have a domain of all real numbers. No, our domain is restricted. Okay, our domain means that we have positive x values, so it's not all real numbers. All right, so that one's false. So just those two. All right, let's take a look at the next one. Which point do the graphs of f and g have in common? They have in common the point 1, 0, always. Okay? And then it says for x is greater than 1, the graph of which function increases faster? Okay? And that would be log base 2. Okay, log base 2 of x increases faster. Okay, means the y values get bigger faster. Okay, all right, that's all I got for that page. Let's see what we got next. All right, let's look at a couple of transformations on this. And it says on this one, how does the graph of g of x, where you've got a times log base b of x minus h plus k, differ from the graph of its parent function? Okay. And so what we have is, you know, you have this a, this h, and the k, all right? And this is similar to what we had with the exponential function. When you have the a, it is a multiplier out front, okay? If a is going to be bigger than 1, the absolute value is bigger than 1, then it's going to stretch it, and it's going to make it big, okay? If a is between 0 and 1, then it's going to make it thin, okay? So stretch kind of makes it fat, okay? Compression makes it thin. Okay, the way I think about that is that if your value of a is big, okay, it's going to make it fat, all right, and then a compression is going to make it thin, okay, and then if you have a is negative, then it's going to be a reflection over the x-axis, okay. H is your horizontal translation. Okay, and k is your vertical translation. So just like what we've seen before, okay, and that's what we've got. I'm going to let you guys work on this next problem on your own, but I'm going to go ahead and stop this video and kind of give you guys some time to work on the assignment. So hopefully logarithms aren't as scary as they were before. Hopefully you have fun. And that's the goal.